We're going to talk today about the difference between dependent and independent events in probability. In the past, we've just been working with independent events, like the compound events we just talked about, where you might, for example, spin a spinner and then roll a die. An independent event is defined as an outcome which is not influenced by a previous event and does not influence later events. If I spin a spinner, that doesn't necessarily influence in any way me rolling a die. If I flip a coin and then flip it again and then flip it again, none of those events will actually influence the other events. When we talk about dependent events, it's a little bit different. A dependent event is an event where the outcome is influenced by previous events or influences later events. So let me give you an example of that after you copy these definitions down into your notes. In this example, I have a fish tank which has no water, and in that fish tank with no water, there are 4 pink fish, 3 blue fish, and 2 purple fish. If the question says what is the probability of picking a pink fish, replacing it, and then picking a pink fish again, let's envision what it looks like when I take a pink fish. So I take it out, and then I put it right back. And then I pick again. Well, me taking it out and then putting it back means the second event is not in any way influenced by the first one because I put the fish back. Therefore, I say these events are independent because neither one affects the amount of pink fish in the tank or the total amount of fish. Because this is an independent event, we know that the probability is simply the probability of event A times the probability of event B. Okay, so if we're finding the probability of event A, picking a pink fish, we say, okay, there's 4 pink fish, so that's our favorable outcomes. And we put that over the total amount of outcomes. So we have 9 total fish, and that's the probability of event A. And then the probability of picking a pink fish when the amount of pink fish has not changed is exactly the same. There's still 4 pink fish in the tank, and there's still 9 fish total. So our probability of picking a pink fish twice, replacing it in between, is 16 over 81. That's our probability. And if we use our calculator to convert that, we'll get 0.198 or 19.8% chance of picking a pink fish twice, replacing it both times. Let's just review really quickly so you know what you absolutely need to have in your notes. If I'm replacing the fish in between picks, then the events are independent. The probability of any independent event is simply multiplying the probability of the first event times the second event, or if there were more events than that, you would continue multiplying and nothing changes. Here the probability of picking a pink fish stays the same, because I put it back after I did my first pick. Now let's see what happens if we don't put that pink fish back. Now our problem reads, what is the probability of picking a pink fish, not replacing, and then picking a pink fish again? This changes the problem. It now becomes dependent, because if I pick a pink fish, now there's only 3 left, and the total amount of fish has also decreased. It's the same tank. That means that these events have now become dependent. The second event depends on the first event, and the first event changes the second event. We now have a dependent situation. The probability for a dependent situation is almost the same, but you need to take into account the change that has happened. So we write it as the probability of A times the probability of B after A. It's just a fancy way of saying something changed. What happens now? So let's see what happens. Here's our first pick. The probability of picking a pink fish is still 4 out of 9 in this situation because there's 4 pink fish and there's 9 total fish. Okay, but now, if we take out this poor little pink fish, we only have 3 favorable outcomes left now. And we have, how many total outcomes are there? Now there's 8 because there's 1 less fish inside that tank. Let's multiply that out. We'll get 12 over 72. And yes, you do have to reduce your fractions, so that becomes 1 over 6. If we divide 1 by 6, we get 0.166 forever and ever. So we'll just round that to 16.7%. So this percentage is obviously different than the first percentage we got. This has changed because we've now modified the original tank. So the first event influenced the second event. Now there's less pink fish, and there's actually less total fish too. So there's the difference between dependent and independent events. You're going to have to use your head a little bit to identify whether or not a situation is dependent or independent. A bag has 5 red marbles, 6 green marbles, and 2 white marbles. What is the probability of picking a red marble, then a white marble, without replacing? So let's start off by saying that, okay, we're not replacing, so that means that the amount of marbles in the bag is going to change for the second event. That means these events are dependent. If we're finding the probability of A, okay, picking a red marble, my amount of favorable outcomes is 5. There's 5 red marbles, and there's a total of 13. 5 plus 6 plus 2. The probability of event B is changed. So now we have the probability of B after A happens. If we've already taken out 1 red marble from the bag, well, now how many total marbles are there? There's only 12. And there's 2 white marbles still, because we're assuming we didn't pick white the first time. There's still 2 favorable outcomes. So we say 2 over 12 total, because we've taken 1 marble away after this event happened. Okay, so going ahead and multiplying this out, we'll get 5 times 2 over 13 times 12, so we'll get 10 over 156. And when we divide 10 by 156, we get 0.0641, which we can revise to say that's about 6.41%. So that's saying the chances of picking this exact combination of marbles out of a bag is really pretty small. Good luck with that.